Alright, so now we are getting ready to start talking about multi-step inequalities. So here I have 55 plus 25x is greater than or equal to 250 plus 10x. So we first want to solve it just like as if we had an equal sign there. So let's go ahead and look at that. I want my variables on one side and numbers on the other. So you could still draw the little line we've been drawing in class and just keep your inequality consistent as we go. I want to subtract 10x because I like for the big number to be on top here when we're subtracting. It just makes it easier when you're dealing with positive numbers instead of negatives. So 25x minus 10x. That leaves us with 15x. Go ahead and bring down everything else that you didn't mess with. So I'm going to bring down that 250 and bring down that 55 over here. There's a plus sign there. Okay, I see that this canceled out, so go ahead and do that. So now we're left with 55 plus 15x is greater than or equal to 250. Okay, so I still need this x by itself. We're going to work away from the variable first. So subtract that 55 on both sides. Remember, what you do to one side, on one side of the line, you have to do to the other. And you can only do it with the when you combine the like terms. So see, there are no variables on the right side, so we can do that. And we don't need to subtract the 55 from 15x either, because there's not a variable attached to that 55, so you can't combine those. So we're left with 15x on the left side is greater than or equal to 250 minus 55. So we have 195 on that side. So now we still have 15 times x is greater than or equal to 195. So you should probably be seeing how this is very similar to multi-step equations. And now we just have inequalities. So right here we're going to divide 15x divided by 15 to get the x by itself is greater than or equal to 195 divided by 15. So we're left with x is greater than or equal to 13. Now on the next page we're going to talk about how to graph this. So we're going to graph it in a different way. We're going to have a number line. So, typically we would have, the 10, 11, 12, 13. So we're going to call this 13. We have 10, and then we have some numbers off to the left, but I'm not as concerned about that. And then after 13, we'd have 14, so on and so forth, 15. Okay, so I know that it is going to be a closed circle because it's x is greater than or equal to, which means it exists at 13. Let's pretend for a moment, I'm just going to erase this piece right here. Let's pretend on this number line I was just going to write x is equal to 13. Well, that would be easy. I would just put a little dot at 13. Well, it's the same deal. We're saying it's equal to, but in this case, it's greater than or equal to. So we know it can not only be 13, but it can be more than 13. So it could be 14, it could be 15, it could be 2,185. It just keeps going. So I'd like to draw a little arrow. This is what we'll want you to do. And I like to also draw it above the number line, because if I drew it on the number line, like your pencil and this black marker, they kind of look the same. So it's best to kind of make sure it's very clear. So I clearly closed in the circle, and I put the little line above and going towards the right, because I'm saying x is greater than or equal to 13. I also want to show a different example. I'm not going to worry about solving out the multiple equations right now, but I'm going to say x is less than, let's say x is less than 4. And if I were to graph that, I'm just going to draw 4 for time's sake. It's not, and we know that this would be 3 and this would be 5. It is not equal to 4. It is greater than 4. So I'm going to draw it's less than 4 in this case. I'm going to draw an open circle because that indicates it doesn't equal 4 because it's all the way up to 4. And I know it's less than, so I'm going to point to the left. X is less than 4. I mean, this could have also been written as 4 is greater than x. That would mean the exact same thing. So don't get confused if your numbers and variables end up on different places than you're used to. It still means the same thing. Think about what the actual phrase is. Really think through. 4 is greater than x. Okay, so if I plug in 3 here, is that true? Yes, 4 is greater than 3. If I plug in 5, is that true? 4 is greater than 5. No, that's not true. So it has to be going in the direction of the 3. I always like to kind of check myself after I've drawn it. If we go back up to the top here, where we were solving this problem, we had x is greater than or equal to 13. If we plugged in 12, we know 12 is not greater than or equal to 13. 13 is greater than or equal to because it's equal to, and 14 is greater than or equal to, but 12 is not. So that kind of also gives you just guessing and plugging in for x to see, is it true? Does that value work for this equation? So those are just examples of greater than and less than, as well as the greater than or equal to, where you have to close the circle and an open circle for when it's not equal to. I hope that you found this lesson helpful. Make sure that you're showing up for tutoring or asking questions if problems arise. Have a great day.